I really wasn't sure what I wanted to major in, but someone told me that if you had a degree in math, you could get better jobs. Now, the way I was taught math, I couldn't imagine that anyone would ever pay money to have me do math. But I thought, okay, I believe these people, so I'll major in math. So that's what I did.
Let's go back to your time at Stanford at SOL, because that was a very exciting time for research.
The big announcement of Carmichael was November '84. In the middle of '85, we were working on it and showed that we'd done a lot of numerical tests to show that you could implement a Newton barrier method, as we called it, and run it on a lot of linear programs, and that there was a mathematical equivalence, that you could interpret Carmichael's method as a barrier method with a certain choice of the barrier parameter. And I got to give a talk at the math programming meeting in 1985 about this equivalence. So there was a funny thing that happened. I gave my talk. We're mathematicians, right? So I said, we have this result where if you choose the barrier parameter this way, the steps are the same. And afterwards, this person came running up to me and he said, this is terrible, this is terrible, this is wrong. I said, it's a theorem, it's true. And he said, I don't care, it's terrible. And I thought, well, he may not like it, but it's true. A theorem is true. It's interesting in mathematics often, especially in algorithms, I think, where something comes along later. It seems like a new idea, but if you look at it the right way, it's the same thing that was done before, possibly with a different notation and a different motivation. So it depends on, the application, but I think the individual mathematical excitement is more sort of I've solved that puzzle, I've tied this knot, I've done this and that. Getting the code to work is great because you think, yes, it's actually working, and then seeing the real world thing is just very exciting. Mathematics is running into all these areas that was not important in before and being used in new ways. And this brings new insights. I mean, I think that's the great thing about what research can do, is you have a way, you look at it a certain way, someone comes in from a different area with a different perspective, and it just opens it up.
And how about if we ask the same question, but not in relation to advances in research, but in relation to advances in society, say the role of women, minorities?
So I think women have advanced a lot, but there's a long way to go. And talking to women students at Karate, I can tell that they're not always getting the encouragement to do things that the male students are. Or they're put off by aspects of the profession, math or computer science, that I don't fully understand. Sometimes people will ask me about being a woman, and I'll say, well, it wasn't so nice when people would make these pretty nasty comments to me about being a woman and how you're inferior. And they say, well, that should challenge you, that should make you want to succeed. And it's true that if someone says to you, you're no good, you think, yes, I am. But not everybody reacts that way. Some people say, you say I'm no good, I don't want to be around you. I don't want to be here in this group. So it's not the case that everybody reacts well to criticism.